Today's problem is longest prefix suffix. This is difficulty hard. Given a string S of lowercase English letters, find the length of the longest prefix, which is also a suffix. Note, prefix and suffix can be overlapping, but they should not be equal to the entire string. Okay. So let's see. Let's get some examples here. ABAB, longest prefix and suffix would be AB. Example number 2, longest prefix and suffix would be AABC, which is a prefix and also a suffix. Here's an overlapping prefix and suffix. AAA, AAA. It did say that the whole string can't be counted as an overlapping prefix and suffix, so we've got three. We've got a three character prefix and suffix. Constraints. Size of the string can go up to 10 to the 6th, 1 million, only lowercase English letters. Company tags, I've heard of a couple of them. Topic tags. Strings and data structures. That's not what I expected to see. All right, this is a hard problem, not because the algorithm itself is so complicated, but just depends. I mean, I don't. It's not a good interview question. Is the thing. If you have some resources at your disposal, you might recognize that the Knuth-Morris-Pratt or KMP pattern matching algorithm, there's a pre-processing step that creates a longest prefix suffix, usually called the LPS array. And so you can use the first part of that algorithm to generate the LPS array, and then just take the last element from that array, which is going to indicate the length of the longest prefix suffix. I think it would be pretty unusual to find somebody, who walks into an interview and, well, I don't know. Maybe I maybe I shouldn't say that. But I think it would be pretty unusual if somebody just knows the KMP algorithm off the top of their head and they just write it out. Now you can see the accuracy here is pretty low, and this is online where people can look up the KMP algorithm if they want to. But anyway, let's see how this would work. Pull this over a little bit, and we can still use the A, B, C. Yeah, we can use that one. So we'll initialize some variables. N is the length of the string. We're going to create an LPS array of integers. That'll be the same length as the input string. Length, that's keeping track of the length, the current length of the longest prefix suffix. And I, which we're going to use to iterate through the string. I is going to start at 1. I of 0, you know what? Actually, let me pause this and draw out the array first. All right, so here's our LPS array. It's a length of 9. I is initialized to 1, length is initialized to 0, n is 9. We start I at 1 because this first character, it doesn't have any kind of proper prefix. I mean, the rules are prefix and suffix can't be the same, so there's nothing we can do with that first the first character in isolation, this A here. All right, so we'll start with I is 1, And we'll go to as long as I is less than 9. Okay, so let's get the character at 1, which is an A. And is it equal to the character at length? I'll put the length on the bottom. And in fact, it is. So length, we will increment that to 1, and longest prefix suffix at I, which is 1, will be 1. Okay. Increment I is now 2. Okay. So the longest prefix suffix we have so far is 1. We have A and A. A is the prefix, A is the suffix. All right, we'll go again. I is less than N, yes. Character at I, which is 2, that's a B. Does that match the character at length, which is 1, an A? It doesn't match. So we drop into the else if length is not equal to 0, which it isn't. Then length equals longest prefix suffix at length minus 1, which is 0. Longest prefix suffix is 0, so length is going to go back to 0. So we are going to have to reconsider our situation here, because right now we don't have a matching prefix and suffix. Okay. We don't increment I. We just do I is less than N, yes. Char at I equals char at length. So char at I, that's B. Char at length is A. They don't equal. So we're into the else. Is it not equal to 0? No, it is equal to 0. So longest prefix suffix at I, 2, is 0, which it already is, and then we'll increment I. Okay, I is now 3. All right, I less than N, yes. 0, 1, 2, 3. All right, so we are there. Char at. Does C equal A? No. So we go into the else. Longest prefix suffix 3 is 0, which it already is, and we increment I. Okay? 4 less than N, yes. And we go to the next letter, which is D. Does D equal A? No. Does length equal 0? Yes. All right, so longest prefix suffix at 4 is 0. Increment I. I is now 5. Okay, 0, 1, 2, 3, 4, 5. All right, so it's A. Does A equal A? Yes. All right, so then length is going to go up to 1. Longest prefix suffix at 5 will equal length. Okay, that's 1. And we'll increment I. 6. We did increment length. So actually length, I should be incrementing that. So length is now here. And I is now here. Okay, does the character at 6 equal the character at 1? Yes, they're both A's. So length is incremented. Longest prefix suffix at 6 is 2. Okay. Let's see, length. So we increment that. It's now here. It's now pointing here. I is also incremented. Okay. Now it's pointing here. Does the index at 7 equal the index at 2? Yes, they're both B's. So length is incremented again, 3. So length is taking us here. Longest prefix suffix at 7 is 3. And increment I. I is now here. All right, We'll go again. Is I less than, oh, we didn't increment it. Is 8 less than 9? Yes. Is C equal to C? Those indexes, yes, they are equal. So length is incremented. It's 4. Longest prefix suffix at 8 is 4. And we add 1 to I. I is now, that's the end of the loop. So that is going to drop out of the loop, and we are going to return longest prefix suffix at 9 minus 1, which is 8, which is this right here, the output. And that, in fact, is the correct output. So that's it. It's the LPS pre-processing for the KMP array. And let's turn off the letters and try and run it. Let's see. Get rid of those. Go back to this. Scoot this over. And yeah, let's try it. All right. Well, go ahead and like the video. Subscribe. You get a problem of the day every weekday right in your inbox. And we'll see you next time.